today's lesson, Chapter 2, Section 5. That's what we're going to be working on. Algebra and trigonometry for college readiness. So let's get ourselves going with this. So today we've got three objectives today. Find the intersection of two sets. Solve compound inequalities with the word and. Find the union of two sets of numbers, and then solve compound inequalities with the word or. And then there's going to be some applied questions. Maybe at the end we'll see where we are time-wise if we get to those today. So the first objective we're going to do today is we're going to find the intersection of two sets. So when you think about intersection, you think about things kind of colliding with each other and things that they have kind of in common. You get an intersection on a road. It's where two roads come together, and that intersection is actually where they meet and everything where they meet. So the outside roads before that intersection really don't become part of that set. So when we're talking about an intersection, we can say for any two sets A, the intersection of A and B symbolized as A intersected with B, this upside down kind of N looking type thing in mathematics, that means intersection of two things. So an intersection is defined as follows. So A intersected with B is X such that it is in an element of X and is an element of B. So if you have two sets again, so you've got a set of numbers, you got another set of numbers, the intersection of those two sets is going to be the ones that they have in both sets. So they have to be in both A and B, in both A and B, in order to be kind of that intersection piece of it. So for example, let's say we've got the set 3, 4, 5, 6, and 5, 6, 7. And we want to find the intersection of A and B. And this is how that's read, A and B. So in order to do this, we need to list all of the elements of A that are also in B. So if we list all the elements of A, it's 3, 4, 5, and 6, and we list all the elements of B, 5, 6, and 7, the ones that they have in common are 5 and 6. So our intersection for A and B is 5 and 6. They're the ones that they have in common. Okay. So let's kind of go back here and let's do maybe one more example in here. So let's say that we have, let's see if I can get rid of that, it's not going to let me, but let's say that we have A is equal to the set 6, 8, 10, and B is equal to the set 10, 14, and 18. And we want to find A intersected with B, or A and B. Which ones do they have in common? So if we look at which ones they have in common, I'm not going to write it down. You guys aren't going to write it all down. This one doesn't. So 10 and 10 are the only ones that they have in common. So that's my solution. And we could put it as a notation 10. And there it is. And that's how sets are, intersections, or and statements. So when two things intersect, they have everything the same. Okay. So now let's go and say, okay, we already did that. Let's talk about compound inequalities that are two inequalities linked by consecutive words such as and or or. And these are what we call compound inequalities. Compound inequalities are two inequalities linked by consecutive words like and or or. So and would be an intersection, or we'll talk about it here in just a little bit is what we're going to call a union. But let's talk about probably just the word and here for just a little bit. So here are some examples of compound inequalities. You've got x plus 1 is less than or equal to 9, and x minus 2 is greater than or equal to 3. That's an example of a compound inequality with the word and. Here's an example of a compound inequality with the word or between them. Okay. And those are just the different kinds of compound inequalities. Well, obviously we want to be able to solve compound inequalities. And the first one we're going to do is we're going to solve the compound equalities with the word and. When you're solving compound inequalities with the word and, you're going to solve each inequality individually. So solve the first one, then solve the second one. Since they're worded with the word and, the solutions of the compound inequality are going to satisfy all conditions that satisfy both of them. And then we're going to graph them, and we're going to look at sets and all of those different things, interval notation and all of those different types of things. So let's take a look at an example. So we're going to solve the inequality, and we're going to graph the solution. Now I'm just going to do this, and then we'll go quick through theirs. Their explanation is way too long. So the first step you always have to do is you have to solve each individually. So we're going to go ahead and solve the left-hand side. X is less than -2. That's the first one. Now add 4 to both sides. X is greater than -8. Okay, so now we're going to graph these. Okay, and we're going to graph these on, this is kind of the steps I use. Okay, we're going to graph these. We're going to graph these on the same number line. So if I graph X is less than -2. So let's say this is 0, this is -2. If I graph all of the points that are less than -2, okay, I've got a less than symbol, so that tells me that I'm going to have a parenthesis at -2, and they are less than -2, so it's going to be everything that goes off in this direction right here. So that's the first one. Now I'm going to go ahead and graph the X is greater than -8. So there's -8. It's it's going to be a parenthesis again. And it's going to be a parenthesis that direction because X is greater than -8. So that's all of the solutions that direction. So now when we're graphing this compound inequality conjunct with the word and, it means that it's the intersection. So it's the ones that they have in common. So the ones that they have in common are all of these points right here. And those are going to be my solutions. So now when you're going to put it in interval notation, you've already seen that there's a parenthesis there, a -8, and a -2, and a parenthesis. So that states that all of our solutions to these two inequalities that they have in common are going to be from -8 to -2. So you graph them separately. We'll put them on the same one. And then in this case with the word and, they're going to come together. Where they come together then is going to be kind of your solution set. If we write it in interval notation. Okay, so let's go through and see how they do it. And again, you'll see this long explanation. They solve individually. They're solving individually, same answers we got. Because their word and, they have to satisfy both. So there's the -2, there's the -8. The solution set is -2, 8. So there's the same thing we had. Okay. So now let's go ahead and solve this compound inequality. And again, we're going to graph the solution. Again, it's converted with the word and. We're going to solve them individually. So start with the left-hand side. I'm going to subtract 4x from both sides, so -4x. So you get -2x is less than or equal to 8. Now I got to divide by -2. Remember, when you divide by -2, that means you have to flip the inequality symbol. So we've got x is greater than or equal to -4. If you want to go ahead now if you want to go ahead and graph that one right now, it's not a bad idea. So there's -4. We'll say that this is 0. So it says x is greater than or equal to. So it's greater than or equal to. So that means I'm going to put a bracket. And it's greater than it. So it's going to go off in this direction. So there's the graph of the first one. Now I'm going to solve the second one. Second one's a little bit easier. Divide by +3, sorry. because we divided by a positive, then we don't have to flip it. It stays exactly the same. So we get x is greater than negative 3. So x is greater than or equal to negative 3. Just double check to make sure I did this right. X is greater than negative 4. Looks right. So go to negative 3. I'm going to put a line at negative 3. It says x is greater than or equal to negative 3. So it's going to be a bracket and it's greater than it. And then it's going to be all numbers in this direction. So our solutions then are the ones that they have in common. So which ones do they have in common? They have all of those in common. So my bottom number is negative 3, goes off to infinity, and we can close it with the open circle, or with the parentheses. So there's the solution for that one. Okay, individually, there's the first one, there's the second one, there's the graph. So negative 3 to infinity is the solution. Set for that one. All right. The next slide, it's just another one. We should be good to go with these, hopefully. We're good with these. You can have an empty set as your solution. Okay, so that's intersections. The next thing we want to do is we want to be able to find the union of two sets. So intersection was what they have in common. You can imagine that union is what they have. So for any two sets A and B, the union of A and B, now this is symbolized, that kind of went out of there with a U. A union B. So this would be A union B. It's just a U, no little turn. So the definition for the union is X such that X is an element of A or. Union is or. It is an element of B. So it's in one of the other. It's in one of them. It's in one or the other. It's all of them that are included. They don't have to be the same when we're talking about unions. So if we're asked to find A union B, if we have A be 3, 4, 5, and 6, and B be 5, 6, and 7, if we want to find A union B, it's all of the elements that are in both. So the set A union B, and again this kind of goes away, is the intersection of all of the elements. So you just really start listing them. So you start listing the ones in A, it's 3, 4, 5, and 6, and then you list any additional ones that are in B. So in this case, just 7 is the one in B. So it's kind of linking them both together and being able to, stop. That's not what I want to do. So I'm going to go back here. It was kind of linking again them both together. So let's look at another one. So let's let A equal 6, 8, and 10, and B be 10, 14, and 20. And we want to find A union B. So we just start listing all the elements in A, 6, 8, and 10, and then you look in B and list the ones that aren't already listed, so 14 and 20. So there is the union. Remember, we talked earlier about intersection. Intersection means it has to be in both. So if we looked at the intersection of this one, there's only one of them that's in both of them, and that's 10. So you got to keep them straight. Union is all of the elements, in doesn't matter which one. And then intersection is the ones that they have in common. So then we want to be able to not only do this part, but we also want to be able to solve compound inequalities with the word or. So for example, we want to be able to do this. Now they're with the word or. Now I'm going to tell you, when you're doing this, you follow the same steps you did before. We're going to do one, we're going to graph. We're going to do the other, we're going to graph. And then we'll see what happens kind of in the end. So we're going to graph, do these separately. So add 1. So x is greater than 3. I'm going to go ahead on my number line and I'm going to graph this now. So there's 0, there's 3. It's a parentheses and it says it's greater than 3. So it's a parentheses. Greater than 3 means I shade everything over here, and it goes off in that direction. Now I'm going to solve the second one. I'm going to subtract 5, and I'm going to subtract 2x. So that gives me x is less than 1. So now x is less than 1. So there's 1. It's less than 1 this time, so it's going to go this direction. And now that is all of these right here. And this happens a lot, most of the time when you're talking about or statements. Or statements are going to go out from each other. I kind of think about it as being a boat. You got a boat sitting here, and you've got these oars outside of it, and those oars are rowing. Okay. Row the boat. You row the boat with oars. Oars point out from the boat. So oars, when you're graphing them, are going to point out from each other. Okay? Ands are in. I don't know, I remember that one, the oars. But oars go out. Oars row a boat. So anytime you have oars, they should be going away from each other. Yes, they're going away from each other. So now if you're going to write the interval notation, so we've got really two intervals to write here. It either goes from negative infinity, and this was 1, to 1, and it's parentheses, or it goes from 3 to infinity. And again, it's parentheses because of this, and it's parentheses on the other end because infinity and negative infinity are always with it. So ors are going to go out, ands are going to go in. Here's their explanation. Choo, 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 choo. Same thing we did. Okay, let's look at a second one. Solve them separately. So add 2. So 3x is less than or equal to 15. X is less than or equal to 5. I'm going to go ahead and graph that. There's 0. There's 5. It's less than or equal to it, so that's a bracket, and that bracket is going to go this direction. It's less than 5, so it's all of these over here. I'm going to change colors. Yellow sounds good. Subtract 5. So x to 2. Okay, now it says x is less than or equal to 2. Okay, so this is going to be kind of one of those that kind of defies, the general rule of or and going away from each other. Again, it happens every once in a while. Most of the time, your ors are going to go away from each other. In this case, they're not going to, so you got to be a little bit careful. This happens occasionally. You've got or 2, and it's going to be less than it, so it's this direction. But now what you have to remember is that your solutions in an or statement are the ones that are in it. So because the 2 is encased in there, our solution for this is going to be from negative infinity to 5 in this one. Okay. And it's kind of one of those odd ones that they don't always go out from each other. That's what I want to kind of look for, but it doesn't always happen. So there it is. So let's look at theirs. Okay, the solutions are, like we said, from negative infinity to 5. So you got to be a little careful. Sometimes they don't go away from each other, but a lot of times they do. And this one, I'm just going to click through it with them. So in this case, it's less than 5 or greater than 2. So again, these are, kind of one of those that don't go away from each other, but they face different directions. If you notice, they do kind of go away from each other. But if you kind of look at this graph and think about what's happening and remember what a union is, if everything's covered, what's my interval notation going to be? Okay, from negative infinity to, that should say positive infinity. From okay. So that really nice timing for, I guess, for my phone to ring, because we're not going to worry about listing this different elements with this stuff. We're really just going to be worried about the first three, the objectives that we had. We're not going to put any applied questions in this one. We're just going to kind of look at these inequalities. So this was section 2.5. We're getting closer. We've got one section left to go in this unit, 2.6, and we'll go from there. So as always, have a great day. We'll talk to you next time.